What is the speed of a particle of mass 10 raised to the power of minus 27 kilogram whose wavelength is 10 raised to the power of minus 8 meters? H, which is our Planck constant, is given as this, right? They ask us what is the speed, which is c. This is what they ask us, c, right? And what is given, mass is given, our m is given as 10 raised to the power minus 27 kg. What again is given, wavelength, which is lambda, is given as 10 raised to the power minus 8 meters, right? Then my Planck constant H is given as 6.63 times 10 raised to the power minus 34 joules second, right? Good. Now, please can you stay with me for some background explanation to some formulas before we can able to answer this question, right? So let's go there. Before we can find our speed, we should recall that energy of a photon, right, is equal to change in mass, or mass times c square, right? Why? Because it has been considered that the photon has two nature, right? The particle nature and the wave nature, right? Good. So we should know this famous equation. Let's call it equation 1. Good. Now also, the energy of that photon is the same thing as what? Hf. Planck constant times the frequency, right? And we should recall that my speed of light is equal to wave frequency times my wavelength, which is my lambda, right? Now if I make f the subject formula by dividing both sides with lambda, this will cancel this, so my f is equal to what? C over lambda, right? The next thing is, from this, let me say equation 2, I'm going to replace where f, I'll replace it with this. Good. So what am I going to have? I'm going to have E is equal to C, Planck constant times C over lambda, right? This is equation 3. Good. The next thing is, let me equate the equation 1 and equation 3. All are energy, right? So what I'm going to have is mc squared equal to